Alright, welcome back everyone. We're doing problem 27 of chapter 9 this time in the OpenStax textbook. Problem 27 reads, a cruise ship with a mass of 1 times 10 to the 7 kilograms strikes a pier at a speed of 0.75 meters per second. It comes to a rest after traveling 6 meters, damaging the ship, the pier, and the tugboat captain's finances. Calculate the average force exerted on the pier using the concept of impulse. Hint: first, calculate the time it took to bring the ship to rest, assuming a constant force. Alright, so let's write down what we know. Our knowns. So we know that the mass of the ship is 10 to the 7 kilograms. We know that the speed, its v initial, was 0.75 meters per second. And we know that the v final was 0. And we know that it stopped in 6 meters. So it's delta x, 6 meters. Okay. Alright, so let's see, what equations can we use for this? Well, we're talking about average force, so let's write that down. The average force when it comes to impulse equals the delta p, the change in momentum, divided by the change in time. Right? Because if we were to multiply both sides by t, or delta t, we would get the impulse, which is a vector, equals delta p, and that's correct. And this is always a vector as well. Only time is a scalar. Alright, so okay, let's just make sure everything looks good. Alright, so okay, if we know this, just get some space. If we know how to calculate the average force, that's what it's asking. It's saying calculate the average force exerted on the pier using the concept of impulse. So we want to know the time. That's what it said in the hint. Calculate the time it took to bring the ship to rest, assuming a constant force. So we're going to need a kinematic equation for this. And one that you can use is I was trying to remember it, but I'm gonna have to look up what it is. Let's see. We want to use time and velocity and distance. We don't want to use acceleration because we don't actually know what the acceleration is. So that one, I'll write it out. That one is delta x equals 1/2 v final plus v initial times time. Sorry, I'll stop messing with that now. Okay, so this is the equation, the kinematic equation we want to know, the formula. So let's just plug everything we have into the equation. So we know delta x is 6 meters, 1/2. V final is going to be 0 meters per second. And then the initial velocity was 0.75 meters per second. And then t is what we're solving for. So it's just 12. I'll just drop the units. Divided by 0.75. So I'll drop them. Alright. And this should equal t. So let's find out using a calculator. you're good enough, you might be able to do it without a calculator, because this is the same as 12 times 4 over 3. Pretty sure. Anyway, so oops, hold on. So our answer is 16. 16 seconds equals t. And so now we have our delta t, 16 seconds. So that's right. Let's add that to our knowns. Delta t equals 16 seconds. So that's how long it takes for the ship to stop, the cruise ship. And now all we have to do is plug everything in because we know our velocities, we know our mass, and now we know our delta t. So the average force equals 10 to the power of 7, and then our velocity, which was 0.75. It's going to want our initial before impact. And then the amount of time it takes to stop. So 16 seconds. I'll drop the units for that. And this should give us our solution here. So just plug this into your calculator. 0.75 divided by 16. And we see that we do indeed get 4.69 times 10 to the 5. And this should be in newtons. Just write this out. So the average force it took to stop the ship was 4.96 times 10 to the 5 newtons. And just remember to use the impulse equation if you're unfamiliar with the average force. We can derive this again using impulse equals delta p, and then we know that impulse is it equals delta p, but it also equals the average force times delta t. So if we know that, we can simply set this equal to each other. Just pretend I wrote AVG there. Times delta t, and then we just divide both sides by delta t, and that's your average force. Yeah, and that's it. If you enjoyed the video and have found it helpful, make sure you leave a like and comment down below any questions you have. And yeah, thanks for watching.